Hi guys. We are starting a new series, right? So that the new series will be corresponding to which one? This is the most repeated concepts of highway in GATE, right? Highway engineering concepts in GATE. And in today's class, we'll be starting the most important concept, that is first concept, stopping sight distance, right? We'll be going for which one? This is a stopping sight distance, right? Can you imagine how many questions came? So here there is only 1 year they did not give GATE question from this one, except that 1 or 2 years, right? Every year there was a GATE question from the sight distances, right? Especially most repeated sight distance question will be stopping sight distance, right? So don't miss this, all of you. Right, here we are going to discuss the concepts of this one. Here if you just observe, what is that? Whenever you are traveling in a vehicle, what happens when you are traveling in a vehicle? Suppose if you are observing some standing object is there, or this standing animal is there, right? Whatever it is, stationary one is there. So by looking at that, right, at this place you are observing that there is some hazard, right? Hazard detected, and after that what happens, right? Immediately after that will you apply brakes? No. So you will be thinking, this is your reaction distance or thinking distance. You will be thinking, or you will be analyzing about this, that entire PIEV process will be going on. Perception, observing the information of this object, analyzing that, recollecting the previous similar situations, that is interaction time. Next, based on that you will be feeling some emotion, right? Which kind of emotion? By looking at this stationary object you will get an emotion like a fear, na? Hurry, or if you go and hit that object, so it will be dangerous, like the fear kind of emotion. Based on this emotion we'll be taking a decision, that is your application of brakes, right? So that is volition time. Here, so that entire PIEV process to happen, your mind is thinking that distance traveled during the time is your reaction distance or this lag distance. After that, what is the decision we'll take to apply brakes, na? So after this entire thinking is over, we'll start applying brakes. But can you apply sudden brakes? If you are applying sudden brakes, na, it will become Doom 29, 26. So we are not making a Doom movie here practically. Then what we have to do? We have to apply the brakes slowly. So that what will happen? We are traveling for some distance. When you are applying the brakes also, then your vehicle will come to this complete stop just in front of this object, right? The car stands still just in front of this object. That is your, which one you can say? It will be stopped. That is your critical most condition, if you just consider, right? Now coming to this, what is it happening in a further detailed manner, if you just observe? So the driver will be seeing that obstruction, there is an obstruction, or stationary object you can say. Then the driver, what happens, right, from here to this point to this point, so what the driver will be doing? That fellow will be thinking, na? So that distance is your thinking distance or this lag distance. Then you start apply, the driver applies the brakes at this second point, then this is your car stopping point finally, so that accident will be avoided, right? This is your total stopping distance. So total distance utilized for stopping purpose, over which visibility is required, right? That is your SSD, you can say, right? So during this, what happens? Thinking distance, this purple one is given here, also purple one is shown. We are maintaining that same velocity now up to this, whatever the velocity we are having, we are maintaining the same velocity here. But from this point onwards, second point onwards, brakes are applied, therefore that friction will start developing. Now what happens to the speed? Speed gets reduced, and finally the speed will become which one? This is 0 at this place, isn't it? So like that, speed is reduced gradually and becomes 0 after some time, right? This is your reaction time, and what is this time? You can say this is your braking time, during which that we are applying the brakes, if you just observe, right? Like that. Now here if you consider this, so what is that we'll be considering? You can say here, first of all, that SSD expression, if you just consider, right? SSD expression will be which one? That is given as your Vt plus V square by 2G into F neta plus or minus N, right? This is the general expression for which one? This SSD you can say. So what is this expression is telling? This SSD you'll be getting in meters, and that speed V we have to substitute in which one? This meter per second, and this reaction time small t you have to substitute in seconds, and this coefficient of this friction, which friction? Longitudinal friction, brake efficiency, and this gradient. These are all we have to substitute which values you can say? Decimal values we have to substitute, or you can also substitute which values you can say? Ratio values we have to substitute, right? Don't substitute the percentage values if you just observe, right? Now coming to this, or it is also given by another expression, right? What is that? Another expression you can say that SSD will be equal to, what is it you can say? 0.278 into that capital V into that small t, plus what is it you can say? Capital V square divided by 254, right? Capital V square divided by 254 into what is that if you just observe? 254 into same f neta plus or minus n. The only change has occurred. What is that? Only one change has occurred if you just observe here. That is your speed, na? Except speed, remaining everything will be same only or not? That SSD will be getting in meters. Speed capital V symbol given means we have to substitute in which units? Kilometers per hour. Remaining everything will be in the same units, right? Like that. If speed, design speed of this vehicle is given on a particular road in meter per second, use the left value. If it is given in kilometers per hour, use the right value, right? Now here, what is that F you can say if you just observe? F is your coefficient of what you can say? It is a coefficient of this longitudinal friction. Why it is taken only that a longitudinal friction or coefficient of this rolling friction? You call it as the coefficient of this longitudinal friction or this coefficient of this rolling friction. And because whenever you are traveling na, so that vehicle will be traveling in this forward direction only, and that in the length direction of this road, when it is observed that brakes are applied, right? So that it is traveling in the forward direction only, therefore that friction is also developed in the longitudinal direction of your road only. Therefore it must be which one? Coefficient of friction into that normal reaction n dash you can say. So that coefficient of friction will be corresponding to this length direction, that is your longitudinal coefficient of friction. Now what is that neta you can say? Neta is nothing but your brake efficiency. Do you give guarantee that vehicle will be having 100% brake efficiency always? No. Brake efficiency of which one? This vehicle. What is that n you can say if you just observe? N is nothing but your gradient if you just observe. So gradient means it is also that longitudinal slope only, absolutely or not? That is also longitudinal slope only you can say, right? Now coming to this, right? Suppose if f is not given, right? What is that we need to do? If that coefficient of longitudinal friction f is not given in the question, right? What is that we need to do? Tell me. When that coefficient of longitudinal friction is not given, so what is that we need to take? We need to take that f value based on this speed, design speed, kilometers per hour, and this is your coefficient of longitudinal friction. And what are the speed values? That is your lesser than or equal to 30 kmph, 40, next 50 kmph, 60 kmph, next greater than or equal to which one? This 80 kmph na. So what are the longitudinal friction values? 0.35 to 0.4. These are the values, right? Whenever these are 0.35 to 0.4, so how you can say that coefficient of friction will be inversely proportional to the speed? Means higher speed means that a lesser friction 0.35, lesser speed means that a higher friction 0.4. How can you get the remaining values? Just you write them in the increasing order: 0.35, 0.36, 0.37, and this is a 0.38, right? Like that we can remember easily, na? Yes or no? Absolutely, right? If so, among them, right? If that f is not given, we know how to select, right? If a neta brake efficiency is not given, right, then what is it we need to take it? If a brake efficiency is not given, so then let that brake efficiency will be equal to which one? This brake efficiency will be equal to which one? This 100%, right? 100%. Neta, if you wanted to represent in percentages, that is your 100%, right? So that means neta in terms of decimal value 1 we have to substitute, right? Next, suppose if a gradient is not present in the question, you can say if that n gradient we have already mentioned already, yeah, if n is not given in the question, right, then what is it we need to take it? If gradient n is not given in the question, then you take it as which one? This that n will be equal to 0. What is the meaning of this n will be equal to 0? It means that it is a level road. Na? Is there any slope you are having, or there is no slope you are having? You can say there is no slope you are having if you just observe, right? Right. So whenever it is that neta is not given, f is not given, n is not given, we know. So next, what are the two unknowns? Capital V and this T, na? Is that no? Suppose if that reaction time T is not given, when this reaction time T is not given, right, what is that we need to take? So let that small t will be equal to which one? This is 2.5 seconds, right? What is that 2.5 second value? This is your 85th percentile reaction time. It is your 85th percentile reaction time as per which one? IRC, you can say. Now it is based on what theory if you just observe? It is based on what theory? It is based on this PIEV theory. Perception, intellection, emotion and this volition theory, you can say, if you just observe, right? Like that. Now suppose if that speed is not given, then what is that we need to take it? If that a capital V or this small v not given. So whenever these are not given, na, so we have to take this standard values definitely, right? What are these standard values? Whenever it is an urban road. For urban roads, right, what are the different types of roads we are having? Arterial street, subarterial street, is no? Arterial street, subarterial street. Next, collector street and this local street. If you just observe, right, what is the design speed we have to consider? That is your 80 kilometers per hour. And what is it you can say? This is 30 kilometers per hour local street. Next, what is it you can say? You just subtract 20 from here, add 20 here. Then it will become this 50. If you are adding 20 to this, 50 kmph. Then what is that? Subtract 20 there. Then it will become this 60 kilometers per hour, right? This is for which roads you can say? Urban roads. And now, whenever you are going for these rural roads, if you just consider, what is that for this rural roads we have to take it, right? So national highway, state highway and everything is there now. So in this also I'll be adding for this expressway, right? Whenever it is an expressway, it will come under both urban as well as rural. Na? So expressway will be how many kilometers per hour you can say? That is your 120 kilometers per hour you can say if you just observe. Now for this rural roads if you are selecting, if you are supposed to remember, you remember only for this one national highway and this is state highway. So what is that? If it is a plain and a rolling terrain, next rolling terrain. What are the different types of terrains you are having? Plain terrain, rolling terrain, and what is it you can say next one? That is your hilly terrain or this mountainous terrain. Next one is your steep terrain if you just observe, right? Like that. Now here 100 kmph to 80 kmph we have to take it, right? So what is that first value if you just observe? That is your which one? This ruling design speed, na? That is your ruling design speed if you just observe, right? Ruling design speed means, right, do you select any speed greater than this, or we should not select any design speed greater than this? We should not select any speed greater than this definitely, right? Now here what is this second one you can say? If a ruling design speed is not possible, terrain is not supporting, then at least you have to provide which one? This 80 kmph. That is your which one? This minimum design speed. Okay, minimum design speed you have to select. So minimum design speed, right? So your design speed should not be lesser than which one? It should not be lesser than this minimum design speed, and it should not be greater than this rolling design speed. Generally this rolling design speed will be taken as which one? 98th percentile speed. 98th percentile, which value? Spot speed. It is not the running speed, it is not the journey speed, spot speed only. So here what is that you can say? Again same 80 kilometers per hour, and what is that you can say? 65. Okay, so now what is that you can say? If you just observe, this is your 60 50, and 50 you can say that is your 40. Okay, like that we'll be having if you just observe, right? These are the values you are having for these speeds, right? What are the speeds you are having? Yeah, actually these values are which one? Ruling design speed values, right? What are these ruling design speed values? Anybody remember these values? Ruling design speed for this national highway and this plain terrain, national highway and this state highway in this hilly terrain. Anyone remember? So here if you just observe, right, if you are remembering these values now, right, what are these values? You can say 180, right? 180 definitely. Next 80 65. Next after that, right, what it will become? You can say 50 40, and this 40 30 it will become, right? So what is that you can say? Hilly terrain, it is 50. There is a break occurs here, right? This is your 50 40, it is not 60 50. And so 65, because we don't use that 60 mostly, and in some of the cases we'll be using practically, but IRC has not defined this. Next, what is it you can say? That is your 40 30. Here that break has happened, right? 180 80 65. Next, it is starting from 50 50 40 40 30, right, like that. So here among them, first speed will be ruling design speed, and second speed will be which one? This minimum design speed, right? First will be that ruling design speed, and the second will be which one? This is minimum design speed in all categories, right? This is your ruling design speed, and this is your which one? This is minimum design speed. Okay, now here what is that condition considered for this SSD? If you are considering this, for these conditions we need to have which one? We need to have what conditions? It is your safe stopping. So what is the meaning of this safe stopping? You can say safe stopping with skid or without any skid. If you just observe, that is without any skid, right? So vehicle is stopped and without any skid, right? That is very very important, right? Now if a vehicle stops, right, if vehicle does not stop, if a vehicle is not stopping, right, then what is that we need to take? If a vehicle does not stop, right, for which purpose? To avoid collision, na? If vehicle does not stop to avoid collision, then what is that we need to take it? If you just observe, then what is that we need to take it? If you consider everyone, vehicle does not stop to avoid the collision, let us say. So here this is your which one? This is V1 only, and from here to here it is traveling V1 to that V1 only, A1 to this A2, it is traveling with the V1 speed only. So that is your which distance? You can say the first and foremost one, this lag distance, na? That is your lag distance. Now we start applying brakes, right, and at this place, right, what is happening? Just in front of this object there is some space available. Then do you need to stop, or you can just reduce the speed and you can just reduce the speed and take side and go. You can reduce the speed and take side and go, na? But for that purpose also we have to apply the brakes slowly, and then whenever you are applying the brakes slowly, that friction will be generated, na? Right. So what is this distance? You can say that a distance will be your braking distance, if you just observe, right? So what is this distance? SB, that is your brake distance or this braking distance, na? Like that. Then in that case, right, what is the SSD will be modified? You can say that is V1 into that T plus what is that you can say? That is your V1 square minus this V2 square divided by which one? This 2G into that F theta plus or minus which one? This N as it is, right? So if that vehicle is stopped V2 0, when V2 becomes 0, it is a first equation as it is you are getting, na? First equation, original equation you are getting, or not? Absolutely right. Or you can also write it as 0.278 capital V into that small t, capital V1 into that small t, plus what is it you can say? Capital V1 square minus this capital V2 square divided by 254 into, right, what is it you can say? That is your F theta plus or minus N. So simply what is that last condition we can consider here? if a vehicle is subjected to skidding, if this skid occurs na, then what is that we need to do? Use what equations? Linear motion equations we need to use. Okay, we need to use which one? These linear motion equations. For what? For this braking distance, that is second part na. So this is second part is your braking distance SB, this first part is your lag distance SL, you can say, right? So what are the linear motion equations? If we just observe that V equal to that U plus AT. Now V square minus this U square equal to that 2AS. And what is another one? S equal to that UT plus which one? This is a half AT square. Okay, like that we'll be having. Now whenever that a retardation, right, what is that a retardation or this deceleration you are getting? If you just observe that A equal to F into G, acceleration due to gravity coefficient of friction into G. If it is given na, you take the given value. If it is not given, take this value, right? Only take it only when? Only if A is not given in question. Only if A is not given in the question, then what is the SSD? It will become, SSD will become, that is your Vt plus V square by 2GF will become which one? This is 2A it will become. So this is about your which one? This SSD concepts, right? This is about your SSD concept, right? But here whenever X only for which condition? Tell me. Only for this single lane two-way condition na? Only for this single lane two-way condition, right? One lane will be there, two-way condition, right? So two-way condition means vehicles are traveling in the opposite directions, right? If the speeds are different na, then what is that you can say? Say for this minimum SSD will be taken equal to which one? 2 times SSD, 2 times SSD, or SSD 1 plus this SSD 2. Now if it is remaining all conditions, right, what is the you can say? Remaining all conditions, right, what is that? SSD, safe SSD. Remaining all conditions, if you just observe na, that is safe or this minimum SSD, right? You can call it as this safe SSD or this minimum SSD or this required SSD as per IRC, right? So what is the safe SSD? You can say that is equal to that one time SSD, that is equal to that one time SSD only, right? Now there are standard values of this SSD given by IRC, right? What is that? As per IRC, if you just observe, so whenever this is your speed, right, 20 kilometers per hour, 30 kilometers per hour, 40 kilometers per hour, what is that you can say? 50, 60, 80, 100. So now tell me what are these SSD values if you just consider. This is SSD in meters na, 20 kmph 20 meter, 30 kmph 30 meter, right, up to the same, right? So 40 kmph, what is it? 45 meter. So 50 kmph, so here 5 increased, here you increase the 10, the difference is doubled. 60 meter, 60 kmph, the difference is doubled, right? So 10 becomes 20 means it will become this 80. So 80 meter, what it will become? 120, 80 kmph it will become 120 meters, right? So the difference doubles means, right, it will become this 180 meters, you can say, right? Is not? So this is how you will be getting which one? These SSDs, standard values and everything. So these are all GATE 2024 tappers from Unacademy. Now at present till this June 5th this offer is going on, so you can get 50% off on your GATE subscriptions, right? Don't miss this, all of you. At 11,999 only will be getting this GATE and ESC subscription, right? Use the referral code RP Civil, all of you, right? So these are the 8 months subscription, right? This is your 8 months subscription will be getting for which one? I plus subscription for 11,999, iconic subscription 8 months for 17,999. What is the referral code you have to use? Always RP Civil is the code you have to use, right? So these are the new batches starting which one? On 15th June, these new batches are starting with KPSR Geotechnical Engineering, right? For new Pratigna batch and everything. Air pollution, it was started already on 30th May for environmental science, right? So those who are taking iconic subscription, these are all the books will be getting delivered to your home, right? Thank you all of you. We'll meet again with one more concept.